finally, Russia shows off its deadly missile factory to the world. Russia's missile manufacturing, efficiency, production, and technological advancements. Shells and strategy, Russia's amped-up ammunition production in the Ukraine war. The war in Ukraine has become a grinding artillery duel, with both sides unleashing a relentless barrage of shells. A key factor in this fight is the vastly different production capabilities of Russia compared to Ukraine's Western allies. Russia's industrial edge in ammunition. Analysis by consulting firm Bain & Company reveals a stark contrast. Russia's armaments industry is churning out artillery shells at a rate 3 times faster and for a mere quarter of the cost compared to what Western nations are currently producing. This translates to an estimated 4-5 million shells manufactured or refurbished by Russia in 2023, compared to a combined 1-3 million from NATO countries and the United States. The ongoing conflict in Ukraine has brought to light the stark contrast between the military production capabilities of Russia and its Western adversaries. Russia's missile manufacturing, in particular, has demonstrated remarkable efficiency, producing missiles at a rate 3 times faster than Ukraine's Western allies and at roughly a quarter of the cost. This video delves into the specifics of Russia's missile production capabilities, the types of missiles used in the Ukraine war, the operational efficiencies of Russian missile factories, the technological prowess of these missiles, and the latest advancements in Russian military technologies. Russia's missile manufacturing efficiency. Speed and cost efficiency. Russia's ability to manufacture missiles swiftly and cost-effectively can be attributed to several key factors. First, the legacy of the Soviet Union's extensive industrial base has provided a robust foundation for modern Russian military production. The integration of state-of-the-art manufacturing techniques with established industrial practices has significantly enhanced production rates. The cost efficiency of Russian missile manufacturing is equally noteworthy. Utilizing domestically sourced materials, leveraging lower labor costs, and employing mass production techniques have enabled Russia to produce missiles at a fraction of the cost incurred by Western nations. This cost advantage is further amplified by Russia's centralized military-industrial complex, which streamlines logistics and reduces overhead expenses. Strategic investments and state support. The Russian government has strategically invested in its defense sector, prioritizing missile production as a critical component of its national security strategy. State support in the form of subsidies, tax incentives, and direct funding has bolstered the capabilities of missile manufacturers. Additionally, the integration of research and development R&D with production facilities has facilitated rapid innovation and implementation of advanced technologies. Types of missiles used by Russia in the Ukraine war. Tactical ballistic missiles. Russia has deployed a variety of tactical ballistic missiles in the Ukraine conflict. The Iskander-M, a short-range ballistic missile, has been a prominent tool in Russia's arsenal, capable of carrying conventional or nuclear warheads. The Iskander-M boasts a range of up to 500 kilometers and employs advanced guidance systems to enhance accuracy. Its mobility and rapid deployment capabilities make it a formidable asset in the battlefield. Cruise missiles. Cruise missiles, such as the Caliber and Kh-101, have also been extensively used by Russia in the Ukraine war. The Caliber, known for its versatility, can be launched from submarines, surface ships, and aircraft. It has a range of up to 500 kilometers and is equipped with advanced navigation systems. The Kh-101, an air-launched cruise missile, features low observable technology, making it difficult to detect and intercept. Both missiles are capable of delivering precise strikes against high-value targets. Hypersonic missiles. Hypersonic missiles represent a cutting-edge technology in Russia's missile arsenal. The Kinjal Dagger missile, an air-launched hypersonic weapon, has been employed in the Ukraine conflict. With speeds exceeding Mach 10 and a range of approximately 2,000 kilometers, the Kinjal can evade most modern air defense systems. Its ability to deliver conventional or nuclear warheads adds a strategic dimension to Russia's military capabilities. Anti-ship missiles. The P-800 Onyx and the Bastion coastal defense system have been used by Russia to target naval assets in the Black Sea. The P-800 Onyx, with a range of 600 kilometers and supersonic speed, poses a significant threat to enemy vessels. The Bastion system, capable of launching multiple Onyx missiles, provides a robust coastal defense capability. Russian missile factory production. Manufacturing infrastructure. Russia's missile production infrastructure is characterized by a network of state-owned enterprises and private contractors. Key facilities, such as the Votkinsk Machine Building Plant and the Tactical Missiles Corporation, are equipped with advanced manufacturing equipment and employ a highly skilled workforce. These factories utilize automated production lines, precision machining, and rigorous quality control processes to ensure the reliability and performance of their missiles. Production processes. The production process for Russian missiles involves several stages, including design, prototyping, testing, and mass production. The integration of computer-aided design CAD and computer-aided manufacturing CAM technologies has streamlined the design and prototyping phases. Additive manufacturing, or 3D printing, is increasingly being used to produce complex missile components, reducing production time and costs. Quality control is a critical aspect of the production process. Rigorous testing, including static and dynamic tests, ensures that each missile meets stringent performance standards. The use of simulation technologies allows for the virtual testing of missile systems, further enhancing the reliability of the final product. Workforce and expertise. The Russian missile manufacturing sector benefits from a highly skilled workforce with expertise in aerospace engineering, materials science, and electronics. Educational institutions and specialized training programs play a crucial role in developing and maintaining this expertise. Collaboration between industry and academia fosters innovation and ensures a continuous supply of skilled personnel. Russia's missile capabilities. Precision and accuracy. Russian missiles are renowned for their precision and accuracy. Advanced guidance systems, including inertial navigation, satellite navigation, and terrain contour matching, enable these missiles to strike targets with high accuracy. The integration of artificial intelligence AI and machine learning ML technologies has further enhanced the targeting capabilities of Russian missiles. Survivability and stealth. Survivability and stealth are critical attributes of modern missiles. Russian missile designers have focused on reducing the radar cross-section RCS of their missiles to minimize detectability. The use of composite materials, stealth coatings, and innovative aerodynamic designs contribute to the low observable characteristics of these missiles. Additionally, the ability to maneuver at high speeds and perform evasive actions increases their chances of penetrating enemy defenses. Payload versatility. Russian missiles are capable of carrying a wide range of payloads, including conventional explosives, cluster munitions, and nuclear warheads. This versatility allows for the deployment of missiles in various tactical and strategic scenarios. The modular design of some missile systems enables the integration of different warhead types, enhancing operational flexibility. Range and speed. The range and speed of Russian missiles provide a significant strategic advantage. Long-range missiles, such as the Caliber and Kh-101, enable Russia to project power over vast distances. Hypersonic missiles, like the Kinjal, offer unparalleled speed, reducing the time available for enemy defenses to react. The combination of range and speed makes these missiles a formidable tool in both offensive and defensive operations. Russia's new missile development. Hypersonic glide vehicles. One of the most significant advancements in Russian missile technology is the development of hypersonic glide vehicles HGVs. The Avangard HGV, capable of traveling at speeds exceeding Mach 20, represents a quantum leap in missile technology. Launched atop an intercontinental ballistic missile ICBM, the Avangard can maneuver unpredictably, making it nearly impossible to intercept. Its ability to carry a nuclear warhead adds a strategic deterrent value. Anti-access area denial A2AD capabilities. Russia has focused on enhancing its anti-access area denial A2AD capabilities to protect its interest and deter potential adversaries. The development of advanced coastal defense systems, such as the Bastion P, and long-range anti-ship missiles, like the Zircon, underscores this strategy. The Zircon, a hypersonic anti-ship missile, is designed to target aircraft carriers and other high-value naval assets, reinforcing Russia's A2AD posture. Integration of artificial intelligence. The integration of artificial intelligence (AI) into missile systems represents a significant advancement in Russian military technology. AI algorithms enhance the guidance and targeting capabilities of missiles, allowing for adaptive responses to changing battlefield conditions. Machine learning (ML) techniques enable missiles to analyze sensor data in real time, improving accuracy and effectiveness. Directed energy weapons. Russia is also exploring the development of directed energy weapons DEWs, such as laser and microwave systems, for missile defense and offensive operations. These technologies offer the potential to disable or destroy enemy missiles and aircraft with high precision and minimal collateral damage. The integration of DEWs into existing missile systems could provide a new layer of defense and offensive capability. Russia's new military technologies. Advanced air defense systems. Russia's S-400 and S-500 air defense systems represent the pinnacle of advanced military technology. The S-400, capable of targeting aircraft, drones, and ballistic missiles at ranges up to 400 kilometers, is a key component of Russia's air defense strategy. The S-500, with its extended range and ability to engage hypersonic targets, provides an even more formidable defense capability. These systems integrate radar, missile launchers, and command and control units to create a comprehensive air defense network. Electronic warfare. Electronic warfare is a critical aspect of modern military operations, and Russia has made significant strides in this domain. The Krasukha and Murmansk systems are designed to disrupt enemy communications, radar, and navigation systems. By jamming and spoofing electronic signals, these systems can degrade the effectiveness of enemy forces and protect Russian assets. Unmanned systems. Unmanned systems, including drones and autonomous vehicles, are increasingly being integrated into Russia's military operations. The Orion and Okhotnik drones provide reconnaissance, surveillance, and strike capabilities. Autonomous underwater vehicles (OVs) and unmanned ground vehicles (UGVs) enhance situational awareness and operational flexibility. The development of these systems reflects Russia's commitment to leveraging advanced technologies to enhance its military capabilities. Cyber warfare. Cyber warfare is an integral component of modern military strategy, and Russia has developed sophisticated capabilities in this domain. Cyber units within the Russian military are tasked with conducting offensive and defensive operations in cyberspace. These operations include hacking, information warfare, and the disruption of critical infrastructure. The integration of cyber warfare with traditional military operations enhances Russia's ability to achieve strategic objectives. Artificial intelligence and robotics. The incorporation of artificial intelligence (AI) and robotics into military systems is a key focus for Russia. AI-driven decision support systems, autonomous drones, and robotic combat units are being developed to enhance battlefield effectiveness. The use of AI in command and control systems allows for faster and more accurate decision-making, while robotics provide new capabilities for reconnaissance, logistics, and combat operations. Conclusion. Russia's missile manufacturing capabilities, characterized by rapid production rates and cost efficiency, have played a pivotal role in its military operations in Ukraine. The deployment of a diverse array of missiles, including tactical ballistic missiles, cruise missiles, hypersonic weapons, and anti-ship missiles, underscores Russia's strategic emphasis on advanced missile technology. The efficiency of Russian missile factories, coupled with a highly skilled workforce and cutting-edge production processes, has enabled the rapid development and deployment of these weapons. Moreover, Russia's ongoing advancements in missile technology, including hypersonic glide vehicles, AI integration, directed energy weapons, and advanced air defense systems, highlight its commitment to maintaining a technological edge. The integration of new military technologies, such as electronic warfare, unmanned systems, cyber warfare, and AI-driven robotics, further enhances Russia's military capabilities. As the conflict in Ukraine continues, the impact of Russia's missile manufacturing prowess and technological advancements will remain a critical factor in shaping the dynamics of the battlefield. The ability to produce and deploy advanced missile systems efficiently and cost-effectively provides Russia with a significant strategic advantage, reinforcing its position as a formidable military power.